Okay, now for a quick demonstration on finding the distance between 2 points on a straight line. If we have a little look here, very much like when we worked out the gradient, I'm just going to draw a little line across from there. We remember that where you get 2 points on a straight line, sorry about this, great. Where you get 2 points on a straight line, you can create a little right angle triangle. And what I'm looking for is the distance between here and here. So if we have a look, if we've made a right angle triangle, that's the line across from the right angle. Essentially, that's the hypotenuse. So to find the distance between 2 points on a straight line, we're using Pythagoras. We're using a squared plus b squared equals c squared, where c squared is going to be the square of the distance between these two. So to find a squared, we need to find a. Essentially what we're looking for here is, we're looking again for the rise. And to find the rise, we remember from doing gradient work that it's y2 minus y1 squared. To find b, we're looking for the run. Again, from gradient stuff, we know that to find the run, it's x2 minus x1, and that'll give us b squared equals, and for now we're going to write in distance squared. So that's super handy. When we're working out the distance, the way that we write the formula when we're doing distance on a straight line is to say that d for distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So let's give this one a go. Again, we need to write in let x1, y1 equal, we're going to go with -1, 7. -1, 7. And let x2, y2 equal 4, -5. We write in our formula, distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared, and we're just going to substitute it in. So I'll skip a line so that it doesn't look too cramped, and I'll just move the paper if we run out of room. So x2 minus x1, we've got 4 minus minus 1 squared plus, so 4 minus minus 1 plus y2 minus y1, -5 minus 7 squared. Okay, so the distance is going to equal the square root of 4 minus minus 1 squared is 5 squared plus -5 minus 7 squared is -12 squared, and we end up with the distance being the square root of 25 plus 144. So I'll just shuffle this up. Sorry about that. So the distance is equal to the square root of 144 plus 25 is 169. I'm going to cheat and calculate it at this point. So the square root of 169 equals 13. The distance equals 13. Now there's no measurements here, so 13 units. So just want to give that one a little run through again. When we're finding the distance between 2 points on a straight line, we're finding the hypotenuse of this right angle triangle. A right angle triangle made up of the rise squared plus the run squared, which will equal the distance between these two squared. So we'll reformat that formula so we get that the distance equals the square root of the run, x2 minus x1 squared plus y2 minus y1 squared. And we'll just substitute in our data. So the data that we've got this time is that let x1, y1 equal -17, let x2, y2 equal 4, -5, put a little comma in there. Write in our formula again, the distance is equivalent to the square root of the run, x2 minus x1 squared plus the rise, y2 minus y1 squared. We substituted our numbers in and we got the square root of 169, so the distance is 13 units.